Hello everyone, I'm Yan Fan from Zhejiang University. I'm glad to present our paper, a differential testing approach for evaluating abstract syntax tree mapping algorithms. There are several background concepts around abstract syntax tree mapping algorithms. In the compiler area, an abstract syntax tree is a tree representation of code. An abstract syntax tree is also known as an AST. AST mapping algorithms represent a file revision as two ASTs and calculate mappings of nodes between the ASTs. In compiler to text-based mapping algorithms, AST mapping algorithms can represent changes to syntactic structure of code. Many previous studies have used AST mapping algorithms, such as API recommendation, manual code change patterns, and automated program repair. The accuracy of the used AST mapping algorithms is vital for the correctness of the proposed approaches by previous studies. There are several popular AST mapping algorithms. Furey et al. Proposed a popular algorithm named change distiller. Change distiller represents statements with as leaf nodes. Then, GumTree was proposed by Furey et al. In comparison to change distiller, GumTree considers more fine-grained AST nodes, such as variable name nodes. After that, MTDiff was proposed by Dotzler et al. MTDiff is based on change distiller with 5 optimizations. It also deals with fine-grained AST nodes. Recently, Furey et al. Proposed the iterative Java matcher, also named as IJM. It uses a reduced AST and leverages an adaptation of GumTree to map AST nodes. However, we noticed that it is challenging to evaluate the AST mapping algorithms. Although previous studies proposed several automated measures, such as number of mappings, number of added actions, such measures can only evaluate the cognitive load for a developer to understand the changes output by an algorithm. Previous work has relied heavily on manual analysis to evaluate the accuracy of mappings as generated by an AST mapping algorithm. But it is not feasible to analyze all file revisions by hand. So, we wonder if it is possible to automatically detect the statements with inaccurate mappings. Our approach is based on an assumption. In a file revision, an element often has only one best mapped program element. Based on this assumption, we can infer that if two algorithms inconsistently map a program element, at least one of the algorithms inaccurately maps the element. In the software testing area, this approach is called as differential testing. For example, in the figure, IJM and GumTree map the hash map in the first line to different elements. Based on our developing experience, it is better to map the hash map in the first line to the map in the second line. Both of them are used to describe the type of the field port mapping. The framework of our approach is as follows. The input of our approach is an file revision and mappings of AST nodes as generated by two algorithms, A1 and A2. First, we tokenize the file before and after the revision. Next, we group mappings of nodes as generated by the two algorithms along the statements. Then, we create mappings of statements and tokens. After that, based on mappings of statements and tokens, we calculate statements with inconsistent mappings. Finally, we determine which algorithm generates the inaccurate mapping and output the statements with inaccurate mappings as generated by each algorithm. When two algorithms generate inconsistent mappings, our approach can automatically determine the accurate algorithm. Our basic idea is that if an algorithm maps a more similar program element, than another algorithm, the latter algorithm is likely to make a mistake. For instance, based on the example in the figure and some other examples we observed, we summarize that mapping tokens in the mapped statements is more likely to be accurate. In total, we designed 6 hierarchical measures to compare the similarity between 2 statements and 2 tokens, in which 2 measures are designed for statements and 4 measures are designed for tokens. These measures are designed based on our manual analysis of 575 statements with inconsistent mappings as generated by AST mapping algorithms. To evaluate our approach, we collected 10 Java projects including 263,000 file revisions. We analyzed the 3 AST mapping algorithms named GumTree, MTDiff, and IJM. We randomly sampled 200 statements with inconsistent mappings as generated by GumTree, MTDiff, and IJM, and we invited 12 experts to label inaccurate mappings. We observed that any statements with inaccurate mappings that we detect are highly likely to be correct. Thus, our approach can be used to estimate the lower bound on the effectiveness of AST mapping algorithms. Based on our approach, we found that the studied algorithms generate inaccurate mappings for 20% to 36% of the file revisions. In summary, we propose a differential testing approach for evaluating the accuracy of AST mapping algorithms. Our approach achieves a high precision, and based on our approach, we observe that GumTree, MTDiff, and IJM generate inaccurate mappings for many file revisions. Thank you.
Hello to everybody. My name is Giuseppe Scaniera. I come from University of Basilicata in Italy. I'm the session chair for this session in the blended session room 1. You have attended the first pre-recorded video about the paper, a differential testing approach for evaluating abstract synchrony mapping algorithm. The presenter was Yunrai Fan from College of Computer Science and Technology from Zhejiang University in China. This is a technical paper, and it seems that we have a lot of questions for this very nice research piece of work. And the first question is from Chao Ni. And the question is, how do you define similarity between 2 program elements? Please, Yunrai, provide.
So we define the similarity of program elements as a likelihood that they can be mapped. This is the answer.
Okay, this is a very short answer for a very short question. Do you want to add something else, or do you believe that is enough?
So the likelihood can be defined by many similarity measures. For example, if 2 statements share many identical tokens, they are very likely to be mapped. So their similarity can be very high. This is an example.
Okay. Second question is from Zhang Zhang. And first of all, he congratulates with you for the nice talk, and I hope also for the nice paper you have written. So the question is, why do you compare mappings of statements and tokens as generated by different algorithms? why not directly compare mappings of AST nodes?
So the fact is that in our study, the studied algorithms, GumTree, MTDiff, and IJM use ASTs composed by different AST nodes. So we cannot directly compare mappings of AST nodes. And by projecting mappings of AST nodes into mappings of statements and tokens, it would be more convenient for us to compare the mappings and perform the comparison.
Okay, thank you for answering also this question. We have a question from Michael Pradel. If 20–30% of all mappings are inaccurate, what does this mean for downstream technique that build on IST mapping algorithm? I think that you can provide here your postulation, your intuition about these results.
So our motivation is that there are many techniques that have used the AST mapping algorithms. If so many file revisions are impacted by those inaccurately mapped AST nodes, then the downstream techniques may be significantly impacted. It needs to be further investigated in future work.
Okay, there is another question by Chani that that can be considered related to the last the question by Miguel Pradel, and the question is, why do state-of-the-art STA mapping algorithms generate so many inaccurate mappings? Do they have some underlying limitation? Is there any way to improve the accuracy of the state-of-the-art AST mapping algorithms? So the first part of the question concerns experimental results, while the second part is about maybe future work or what you understand from your research. So some consideration, some postulation founded on your research.
So based on our observation, we guess that the state-of-the-art AST mapping algorithms generate inaccurate mappings because they use mapping heuristics in a sequential way. That is, if an algorithm finds that two program elements satisfy a matching heuristic, for example, identical tree heuristic, or the dice coefficient in change distiller or GumTree, then the algorithm will map the two program elements. However, in practice, the similarity of program elements is impacted by many factors. For example, they may be the similarity of program elements may be impacted by the textual similarity, by their position, and even the semantic factors. So state-of-the-art algorithms lack a framework to combine so many similarity measures and compare the similarity of program elements using the similarity measures at the same time. And on the other hand, from our observation, we found that state-of-the-art AST mapping algorithms have not considered the characteristics of the programming languages. So for different programming languages, the mapping strategies may be different.
Okay, thank you for the in-depth answer to the question by Chani. We have another question from Michael Pradel. Could you use your 6 similarity measures as a standalone mapping technique, and how well would it perform compared to the existing algorithms? I think that you can give here some solution about the second part of the question.
So this is an interesting question. We have we have done this as our recent research, and we have developed we are developing a software tool based on this study, and we not only use the 6 similarity measures as noted in our paper, we have developed another 6 similarity measures to incorporate our AST mapping tools, and our tool has developed with 15,000 lines of Java code, and this paper may be presented soon.
Thank you, Jan Ryan. We have less than 2 minutes in the question and answer part of your talk, and then I think that we have there is room for the last question of the session from Pinjahi, and the question is: are there any typical kinds of mapping errors found in this study? Could you elaborate a bit more on how to use these reported errors to improve the current AST mapping algorithms? You have 1 minute to answer these questions.
So from our observation, there are some errors that are induced by MTDiff or GumTree. That is, if you delete a method and add a method, that they cannot be mapped. But if they have they both have the public keywords, they can be mapped by GumTree and MTDiff. So this is a very obvious error, and from this error, we in our new tool we have developed a similarity a strategy. That is, if two methods cannot be mapped, we do not map their public keywords or static keywords. This is an example.
Thank you. Bye.